Hello everyone. With this video, we will start the second chapter of this program of foundation engineering, which is soil testing, in situ soil testing. And I think from here, things will start to be maybe more interesting or maybe more easier for you to understand. Okay, directly related to practice. And I hope we will learn a lot together. Okay, so this is second chapter in situ soil testing. So here is the content of this chapter. The first part is about introduction of the subsurface exploration, need of in situ testing, geophysical testing method, physical sampling, physical sampling and penetration tests, cone penetration test, field then shear test, pressure meter test, dilatometer test, dynamic cone penetration and California bearing ratio test, borehole shear test, subsoil exploration report, because after doing your field investigation, your in situ testing, you need to write report. So there is a way to report it. These are the main points we are going to discuss in this chapter. Okay, in this video, we will only stay on this first point, the introduction of subsurface exploration. Despite its introduction, it covers a lot of things, and I hope you will learn something. Okay, so let's go with the first part of this chapter, the introduction. Okay, introduction to subsurface exploration. First, we are going to talk about preliminary site exploration. What are you going to do first? Because there are steps you have to follow. So for this design of foundation designers must conduct detailed surface and subsurface exploration. It's not only subsurface, but also surface exploration. Maybe you need to visit the site or something. There are a lot of methods. So it has to be done before deciding on the type of foundation. Because remember, keep in mind that this is foundation engineering. Okay, we are going for foundation engineering. So before you choose the type of foundation, you have to explore to do the surface and subsurface exploration first. Okay, so it's not before that. Investigation program, because you need a program. You need to schedule everything, to program everything. It should be considered depending on the type, size, and the importance of the structure, the building maybe you are going to build. Okay, and determining the number and depth of soil boring needed. Okay, how many points do we need to do the boring, and at which depth do we need to go? Everything will depend. You will see in the following slide that it will depend on the size of the building and the importance of build. Importance means like, for example, if you are going to build just a hospital, it's not same as you are going when you are going to build like a private house, something like that. Hospital, administration, uh, buildings, and maybe schools for kids. So the importance of the building also will affect the number and the depth of boring we are going to do. Okay, so we need to plan. Planning is necessary. So planning should be also included locating like the underground utility. Okay, you cannot just go and dig everywhere without knowing first at this this place maybe there are like pipeline water or gas pipeline or something like that. So we have to consider this also. So there is uh, something we say call before you dig. Okay, so there is a service depending on the country you are. In every country there is service that knows the plan of the underground pipeline. Okay, so you can go and ask for this so that you know this place it's safe to dig, or this place it is not. If we dig we will reach underground pipeline, something like that. Okay, so you should ask permission, you should notice to this service days before you start your digging. Okay, normally it's saying no cost, but it depends on each country. Actually, everything we are going to talk about here will depend on your country. Okay, please be careful. But this is mainly the program in USA, America. Okay, so subsurface exploration and testing especially serve the following purpose, depending to the Federal Highway Administration of USA. As I said, what we are going to see here, mainly in this program, is according to rules and regulation and maybe the, how to say, the norms, okay, of USA. So please be aware of that. Okay, first, why do we need to do subsurface investigation? Okay, following to this standard, US standard, Federal Highway Administration, it will add in preliminary selection of type of structure type considered viable for particular site and the type of superstructure to be supported. Secondly, it will provide a basis for selecting soil and rock property needed for this substructure design. What type of soil we are dealing with or rock we are dealing with. Okay, it will also help identify a special substructure condition requiring special provision to supplement standard construction specification. So for most projects, the following type of subsurface information are needed for selecting design and construction of substructures. First, definition of soil or rock, the boundary between the soil and rock, because in some sites you have bedrock, maybe depending on the site, the bedrock may be near the surface or very deep, or sometimes it doesn't exist at all. So we need to define, okay, where is this bedrock is located. So the boundary, okay. Secondly, variation of the groundwater table. Is there groundwater at the depths we are going to, at which depth this groundwater is? Is it like stable in the whole year, or it will be like changing, the position of the groundwater is changing in a year? The location of adequate foundation bearing layer. As I said, sometimes you may have the bedrock near the surface. Okay, sometimes it's very deep, unreachable. You cannot reach it. So, however, you by doing exploration, you can find at which depths we have higher bearing capacity of the soil. Okay, that means the adequate foundation bearing layer. And for magnitude of structure settlement and heave. Okay, this if you go, you check the soil. If, for example, you have clay in place, you may have to be worried about heave, for example. Okay, depending on the soil you have, you may judge what can be the magnitude, the amount of settlement or heave you can expect. Okay, and also sometimes we need to do the watering. Okay, during the construction, is it necessary? Do we need it? Don't Is it not necessary to do it? So the dewatering requirement during construction also is sometimes needed. So you need to judge if you need dewatering or it is not necessary. It will depend on the type of soil and the level of uh, underground water table. Okay. Number 6, the potential problem that you may uh, have, including building cracks, slope instability, and any other thing. By doing that, you may check if you will have any problem of this type during your construction. And the access, if you are going to build something at a place, you need access to that place. Are there any roads existing already? Do you need to uh, make some road, at least temporary road to access to the place? There are a lot of questions around this. Actually, this is not all everything you need, okay? Because each project is different. But here are the main questions you have to solve for by doing this preliminary site exploration. Okay. So in developing site exploration, the geotechnical engineer should assess also variables such as the type of structure and its importance. I already talked about that before. The loading magnitude and rate. Okay, because if you know the type of structure, maybe you can judge the magnitude of the load that will be coming on your foundation. In the loading rate, that will maybe depend on the construction speed and everything. In the foundation alternative, considering techniques, economic, and constructability factors. Okay, this is from Federal Highway Administration. So we have then two phases: the preliminary investigation and the detailed investigation. Okay, preliminary investigation is just let's say it is not deep, but this one is detailed and final investigation, and this one is very important because depending on this, the cost, this one will affect. If this one is done in wrong way, it will affect the cost, the total cost of the project. Okay, but if this one is done in a very good way, it can save money. As you can see here, there is also economics including. Okay, so the preliminary investigation, we are going to talk about this first. Okay, because as I said, there are two: preliminary investigation and the detailed investigation. So for the preliminary investigation, we want to gather valuable site information with minimal expense. That one, we you will not need to spend a lot of money. Sometimes you can get some information just being in office. Okay, so we are going to talk about the preliminary investigation. Okay, Some information, useful information, can be collected using the following sources. Okay, many information you can get from maps, topographic maps. Okay, this can include land form, ground slope and shape, and stream location. Maybe there are a lot of administration offices that can provide you with this. Okay, and you can get also aerial photography, photographs that can give you this kind of information: landform, soil types, and rock structure and stream types. Okay, sorry, I made mistake with this one. And soil maps is different to uh, topographic. Topography is just the shape, maybe, of the surface of the soil, but this soil map is a soil map maybe will give you also this landform and soil description close to the ground surface. For example, the type of soil, is it sand, is it clay, this kind of thing, but at the surface, not deep down. And also this kind of information, welding logs, that can help for identification of soil and rock, as well as groundwater level at the time. You can also get, if the existing boring load exists, you can get information from these also, depending on the area you are, in the country also. Because some countries have a lot of information that help to get many information. And also there are some local department of transportation can give you some soil manuals, geological survey soil maps. In some countries, if you go, depending the locality where you are, you can get these kind of maps, geological survey soil maps. Okay. Also local hydrological data and local university research publication. So these are information, as you can see, you can get even without going on the construction site. You can get them being in the office or just visiting one service and another. Okay, or going online trying to find some publication, literature review. You can get a lot of information. So that's why this preliminary exploration is cheap, costs less money than the detailed one. Okay, because the detailed one, you have to use heavy equipment and you have to be on the site. Okay, so in addition to reviewing documentation from previous study, previous slide, uh, we can also go on the site, construction site, just for visiting. Okay, it will help a lot to get vital information about the soil and ground. Okay, because receiving a documentation from services and online is not enough. You can just go visiting. Maybe you will notice something that is not included in the documentation you have gathered. So you may maybe see that there is a new construction going on near the site you want to build your structure, or there is a little change of like vegetation, something like that. By going, you can notice, you can have more detail, some detail that photography could not show you. Okay, and it will help to in the efficient selection of the foundation type, because as I said, you have to visit to have to do the site exploration before deciding the type of foundation you are going to use. Okay, and the depths of foundation, at which depths you are going to go, and many other details about the construction. Okay, the site inspection, we are calling that the visit on the site is maybe site inspection can also help save time and money. Okay, can save time and money in foundation construction project by observing topography, accessibility. As I said, you need to get access to the site. Do you need to, are there any road already existing that help to access to the site? Or do you need to build something, at least make like some earth work to make a platform, working platform, something like that. Okay. So accessibility also, by visiting, by doing the site inspection, you can see that very easily. Okay. Groundwater condition, and as I said, neighboring structure, maybe the maps you have are maybe a little bit old, or the documentation you have are old. Maybe there is a new structure that is being built just near the place you want to build. Okay. There are some detail. It only the inspection, site inspection can give it, can give them. Okay. So, and also the inspection of existing buildings performance can also be beneficial. That is very simple and very important. For example, if you want to build a house, a building at a place, and you go that and notice that the building near this location, all these buildings are experiencing excessive settlement, for example. Okay. Then you may think that, maybe I need also to be careful so that my building will not experience excessive settlement. Okay. So checking the performance of existing building near the place is also very important and can help you to save money, because if everything, something went like goes wrong, even if the structure is very good, the the structural engineers did good work, if the foundation are not stable, the whole structure will collapse and it will be just loss of money and loss of time. Okay. So if you go and check the existing building, and even sometime you can get the report, subsurface exploration of those building also nearby, and it can help a lot. Okay. That point is very important. So a preliminary investigation effectively screen all alternative sites for a given installation. So you have to check if the site you have right now is not very good, and if you have several places, you have to check if maybe we can choose, especially if it is the government, they can change the site. Okay. But if maybe you don't have many choices, that will be difficult, I think. Okay. So now let's go for the plan, exploration plan, because you need to make a plan. Like how many uh boreholes you have to do. Okay. What is the distance between the boring places? You have to make a plan for everything. And as I said from the beginning, it will depend on the type of the structure, importance of the structure. Okay, everything. So the site investigation phase of exploration program consists of planning, making test boreholes, and collecting soil sample at desired interval. Okay, maybe every 20 meter, every 100 meter. It will depend on the type of structure you are using. If you are using a highway, you will not be collecting soil samples every 5 meter. You will never finish. Okay. So for subsequent observation and laboratory testing. So it means when you dig the ground, first you can observe the soil that is coming out from this borehole. Is it, you can check the color. You can, only by naked eye, you can also try to see what kind of soil you are dealing with on this site. Okay, before even going to the lab to do your soil, your experiment. Okay, and also, of course, laboratory testing to check the parameters of the soil. Okay, so the approximate required minimum depth of the boring should be predetermined. Okay, you have to determine that before going on the site. Okay, this is included in the planning. At what depths are you going to dig? Okay, as a geotechnical engineer, you have to decide that and give the technician to do so. At which what depth is appropriate for all the body and the distance between the bodies. Okay, the depths can be changed during the work, the drilling operation, depending on the subsoil you have. Okay, at the beginning you may plan something, but once you arrive on the site, you will notice that here it is difficult because the preliminary plan, the plan you will do here first is based on the type of the building. Okay, you will see soon enough, depending on the type of building and the size of building, there are number and depths, number of borehole and the depth of boring that are recommended. But if it is recommended to go, for example, 5 meters or 10 meters, and you go on the site and found that maybe this site is little more complicated, little more complex, it's not uniform. So you may need to change the first plan of the depths of the digging. Maybe you may go deeper than the what was decided before. Okay. So for the detailed investigation, as I said, it will depend on type of and importance of the structure, right? So this Federal Highway Administration of USA is proposing this table to help us decide on the minimal number of boring and the minimal depth of boring. As you can see, this is minimum. It doesn't mean maximum. Okay. So as you can see here, it will depend on the structure. Okay, geotechnical theater. Okay, it will depend on the structure we are dealing with. Okay, so if we go for this kind of situation for foundation, structure foundation, okay, it's saying the Federal Highway Administration is saying that we need one borings per substructure unit for width less or equal to 30 meters. Okay, and we have here regarding the depths of the borings. Okay, first, if we have unsuitable soil, the surface, maybe unsuitable foundation soil. For example, we have peat, highly organic soil, soft, fine-grained soil. Okay, we have to dig through this weak soil, this kind of weak soil, into competent material of suitable bearing capacity. I'm not sure if you understand this, but sometimes you may have that the upper part of the soil, the, the, the site is made of very weak soil. A very strong layer exists beneath that. So in that case, you have to go through, okay, the weak soil and reach that strong layer. That's the meaning. That's the first point. Even if, for example, the requirement is saying, okay, type of building is saying go to 3 meters. The borings should be 3 meters. And you go and find there is a good layer, good strong layer from 5 meters deep depth. So you have to go through the 5 meter of weak soil and reach the strong layer. Okay, disregard what is said in the requirement. Okay, second situation is the depth where the stress increases due to estimate footing load is less than 10% of existing effective soil overburden stress. Don't worry, we will see this one in detail in following slide. But it is saying that, when you build foundation somewhere, for supposing you build footing on the soil, the immediate contact between the footing and the soil at that level, the pressure is very high. But if you go deeper, the pressure added by this footing will decrease. I hope you know that in soil mechanics 1, we have stress in the soil. There is chapter stress in soil. You can see how the stress will decrease when you go in depth. Please be careful. I'm not talking about the effective stress. I'm talking about the stress that is caused by the foundation weight, the loading we are putting on the ground. Okay, so if you go deeper, the stress caused by the load, okay, footing on the load is decreasing. Okay, at the surface of the footing, for example, it will be 100%. Okay, when you go 1 meter deeper, it will decrease. So this point is saying us you have to go until where this stress is 10%, less than 10% of the existing effective soil stress, means sigma v prime, unit weight by the depth multiplied by the depth. Okay, but we will come back on this later because there is another. This is for the Federal Highway Administration, but we will see also another. I think the American Society of Civil Engineering that is also saying, giving the same recommendation. Okay. Number 3 is a minimum of 3 meters into bedrock if bedrock is at the shallower depths. So it means, I think that one is easy to understand. If you have bedrock near the ground surface, you need to dig at least 3 meters in this bedrock. Okay, even if you have bedrock, that bedrock also, the rock maybe like have some cracks or weathered rock, something like that. So you still need to go at least 3 meters to check this. Okay, so this is for this structure foundation. Next, we have here the case. This was the case where the building is main less than 30 meters. Okay, it's saying you have to do one borings for each unit, for each foundation, maybe by structure unit for which for each structure you can do only one. But if the building is, for example, larger than, for example, 30 meters, you have to do two boreholes, two borings in that case. But the depths will be same here. Just the number is different. Okay, less than 30 meters and larger than 30 meters. We go now for, here we have retaining walls. Okay, for retaining walls, the borings alternatively space, because the number here, we need number. Retaining walls maybe long. So the space between two boring, the space between two boring is like between 30 to 60 meters in front of and behind the wall. Please be careful. It is not all here. It is not said in front of or behind. It is said front and behind, both. Okay, this is in case of retaining wall. And regarding the number, okay, the depth, the minimum depth for these borings for a retaining wall, it's saying extend the borings to the depth of 2 times the wall height. So if your retaining wall is 3 meters, you have to go 6 meters depth, or a minimum of 3 meter in bedrock. So if the bedrock is nearby, so you have to go at least 3 meter in that bedrock. This is similar to the previous, the foundation for structures. Okay. Now let's take in case of culvert, bridge, approach, embankment over soft ground. Okay, if you don't know what is this bridge, approach, embankment, it is this kind of embankment. You see here, you have the bridge here, but the transition between the bridge and this normal road, this embankment, you need to do this embankment. Okay, and it's kind of foundation. So this is the meaning of bridge approach embankment. So in case some of you don't know what is this. So for this, we need two borings depending on the length of this, how long it is. Okay, and depending on the depth of boring, it will be same as the structure's foundation, the previous slide. Okay, this is for culverts, maybe small bridges or small. So for bridge approach embankment over soft ground, it is saying we need one boring at each embankment to determine problem associated with stability and settlement of the embankment. Okay, and as note, it's saying that the borings for approach embankment are usually located at a proposed abutment location to serve as dual function. Okay, and in addition, shallow exploration at the approach embankment location are also an economical mean to determine depths of unsuitable surface soil. This is just for the surface soil. Okay. So next we have Also, cut and embankment. If you are going to build a road, sometimes you need to do some cutting. If you have maybe a mountain, but that mountain is not too high to make like tunnel. So in that case, you may just cut that mountain and your road can go through. Okay. And of course, you know that sometimes, maybe almost every time, you need to do embankment to get a desirable level for your road. Okay. So if you don't understand, here is an example. As you can see here, this is cutting. It had to cut here and the road went through this. Okay. But here, however, it is embankment we have here because the road is here, as you can see. So for this kind of cutting, what should we do? For this kind of embankment, what should we do? Because as you know, this is also foundation of the road. Okay. So for this cuts and embankment, it is saying that boring borings typically space every 60 in like non-uniform condition to 60 to 150 meters. Okay. 60 is when the condition are not uniform. Okay. You need to be more careful. But if it is almost uniform, you just go out up to 150 meters. The spacing between one bore, boring to another. Okay. This is for the requirement for the spacing, the number, okay, because the spacing is associated to the number of borings, okay, with at least one boring taking in each separate platform. For example, if you are going to use this, okay, 150, maybe from here to here, you have to get at least one here, one here, at least, okay, at least one boring in each separate landform, okay, not platform. Now for high cuts, maybe this one can be considered as high cuts because some cuts are just few centimeter, few meters. Maybe this one is a little bit higher. For this kind of high cuts and field, this one also can be very high field, okay? Some field are just few centimeters. So for this kind of high cut and fill, two borings along a straight line perpendicular to the center line or planned slope face to establish geological cross section for the analysis. So you need maybe one here and one here, cross section, okay? Perpendicular to the axis of the road for this kind of high cutting and fillings. This is what is said about the number of borings. Okay, let's go now for the minimum depth of boring. For cuts, the first thing is we have to dig, to do the boring into stable material. Okay, cut is here, for example. Extend borings a minimum of 3 to 5 meters below the cut grade. Here is the cut grade. The road level is the cut grade. Remember that before the road, here was field of soil. Okay, this cut was not here. So it was something like this. So it means you have from top here, you have to dig, reach the level of the road, the predicted level of road, and go deeper to 3 or 5 meters. Okay. In weak soil, same. It's still, we are still on cut. Okay. In weak soil, extend the borings below cut grade to firm material. If you have very weak soil at the surface, and you know that there is very strong layer under the grade of the this this level, for example, then you have to go until you reach that very uh, strong layer. Okay. Or the depth of cut cut below grade, whichever occurs the first. So you have two conditions here. Okay. Extend borings below cut to the frame material, or depth of cut below grade, like here. Also, for embankment now, okay, we have finished with cut. Now for embankment, for this case, for this kind of embankment, we have to extend the borings to the frame material, or to depths of twice the height of this embankment. Okay, maybe there is very strong layer just beneath this embankment, so we have to go to reach that layer. If it's unreachable or it doesn't exist at all, we have to go at least twice the height. You see the height of this embankment, at least twice the height of this embankment. Okay, so this is from the Federal Highway Administration of USA. Okay, so this stage of investigation need heavy equipment for boring. Okay, and it's very important to set up definitive plan. You need to set the number, or let's say spacing of borings, and also the depths. You have to set is fix it before going. Okay, because it will affect the cost of this project. So you need to fix the layout of boring, depths, because layout means the location at which place. Okay, depending on the source, the structure you are doing. Where are you going? Even if we know the number and the number of the borings, and also we know the depths, but location where? So we need layout, and also depths of each location. Okay, so you should, as geotechnical engineer, search for subsurface anomaly or weak layers that could undermine the construction. So the criteria for determining the depth of boring are discussed from the next slide. Okay, the depths, despite, don't forget that we have, let me go back, I'm going back. We have already this table from the Federal Highway Administration, but there are also uh, some suggestion we are going to see here. So if the bedrock is nearby, just continue digging until you reach, continue boring until you reach the sound bedrock. Verify by the rock quarry. And even in that case, you remember you need to go at least 3 meters in this, according to the Federal Highway Administration. Okay. If then you don't have bedrock nearby, or if it is unreachable, So there are some specific guidelines for choosing the depth. Okay. Here is guideline proposed by the American Society of Civil Engineering. So as I said, please check the guideline of your country, but I am sure that it will not be much different. This is the guideline proposed in America. If your country is using American code or this kind of thing, then maybe it will be same. But even if it is not, it will be maybe same. Okay, first, you have to determine the net increase in the effective stress. Effective stress. When you are loading the ground, you are increasing the effective stress. And as I explained before, if you are going deeper, the increase of effective stress is decreasing. I mean, the effect of the loading on the ground will decrease when you go deeper. Okay, this figure will explain it very soon. And we have to estimate the variation of effective stress with depth. That one is easy, right? The unit weight multiplied by the depth. Okay, sorry, I have to, yes, this one. So this figure, please forget this first. Okay, let's concentrate on these 2 points. Yes. Okay, the net increase in the effective stress and the variation of the vertical effective stress with depth. Okay, I will explain the difference. Here we have a footing here, and the position of the footing is here. Immediately at this position, do you remember the force, the load coming on here divided by the area of the footing will give us the stress of this footing. That stress plus this the effective stress. Okay, here this level. This is what we have to consider. But that's that stress caused by this load is what we are calling here delta sigma prime, which is different to delta, which is different to sigma zero prime. Sigma zero prime is what you always know. New, I think this is soil mechanics one. I think. Okay, so this is just unit weight multiplied by the depth d, but this one is the force here divided by the area of footing, something like that. So anyway, it is just the stress caused by the foundation. So this stress caused by the foundation at this level of the foundation, it is at the maximum level. And when you go deeper, it is decreasing. Okay, it is decreasing like this. Okay, when you go deeper, maybe it will become zero at certain point, will become zero. But before that, so we need to know at which depth, at each depth, what is the value of this delta sigma prime, the increment, the stress increment that is added by the loading. Okay, so if you understand that, we can proceed with the next point. Point number 3, determine D1 at which the effective stress increase delta sigma prime. This one is, okay, 10%, which is here also. If you want 1/10 of this net stress of the foundation. Okay, net stress of the foundation. This value, C is decreasing, delta sigma prime is decreasing. Maybe at here, if it is 10% of this stress, net stress of the foundation, which means I explain net stress is just the weight divided by the area of the foundation. So if this increase, this delta is less than 10% or less, then at this depth, you can dig, can do the boring until this depth. Okay. So we come back in this, the equation of this, how this is decreasing. There is equation to determine how this decreasing. Okay. Maybe here it is 100%. Maybe here is, I don't know, 70%, 50%, 20%, and maybe here 10%. So at what depths it is 10%, you need to go at this depth. This is D1. D2 is now the ratio between this, the stress increment, means the stress increase, and the effective stress, which is here. Okay. If this ratio, this divided by this, is around 0.05, which is maybe 5%, then you can also decide that your foundation is here. But you compare then these two, D1 and D2, and you take the minimum, the smaller one, because we are trying to save money. Okay. So it just determine the approximate minimum depth of the borings required, unless the bedrock is not existing, unless the bedrock exists somewhere. If you don't have the bedrock, you have to do this kind of calculation. If there is bedrock somewhere, then you go 3 meters deep depth on in this bedrock. So this means you need to know the load coming on this foundation, right? You need to know the approximate weight of the building. Is it how many stories the building have? Depending on the how many stories the building has, you can judge approximately, yeah, how the load that will come. Okay. So if you use the preceding rules, means if you use this, using these rules, okay, the depth of borings for building with the 30 meter width of 30 meter will be approximately the following, according to the following. Okay. So if you have one story building and the building is less than 30 meter, is the larger of the building is less than 30 meters. So you have this approximate depth, 3.5 meters. 2 stories, 6 meters. Okay. 3, 10. 4, 5, 24. This approximative. So roughly speaking, ask what is the length, the dimension of the building. Is it less than 30 meters? If yes, then you can apply this table. Then ask again, how many stories the building have? Is it 1, 2, 3, 5 stories? Then you need this kind of thing. Okay. Or you can do it by yourself using the techniques explained in the previous slide. Okay. So as I said before in the beginning, I said the importance of the building also is affecting the investigation, the exploration work, the exploration plan. If the building is hospital, hospital is a very important building, or office buildings. Okay, for this kind of building, there is formula, these two formula to obtain the depth of borings. If D is in meters, please be careful, because if it is in feet, American unit, it will be different. Here, for example, you will have maybe 20. Okay, but here, if your building is narrow steel and narrow light steel and narrow concrete building, narrow means maybe less than 30 meters, then please do this, and you have S is the number of stories. Is it 1, 2, 3, 4, 5 story? Then if here you have, I mean, here is for, this one is for heavy steel and wide concrete building. Maybe if you have a building with dimension larger than 30 meters, you can use this formula. Okay? S is just the number of stories. If you check in some books, you will see that this formula is given in another way, but it is same formula. Please check. I just made it this way to make it easy for you. Okay. Otherwise, this original formula, it was like a D divided by this S power 0.7 equal to something A, and the value of A is given somewhere. So anyway, it is same. Okay. So when the depths for excavation are anticipated, the depth of the boring should be at least 1.5 times the depth of excavation. Do you understand the meaning? It means that if you are going to build a underground, for example, and the depth of this underground, the digging, the excavation for the underground is fixed already. If it is anticipated, then just do your boring 1.5 times the depth of excavation. Okay, you should be go down lower than the level of the excavation. Okay, sometimes also subsoil condition require that foundation load be transmitted to the bedrock, have to go to reach the bedrock. In that case, as I said before, and I repeat here again, you have to go core boring into the bedrock about 3 meters. Okay. So if the bedrock is irregular or wavered, the core boring may have to be deeper, because if the bedrock is not good, the rock is maybe has like some cracks or it is wavering, you have to go deeper to check the limit of this wavering. Okay. Regarding the rule for the spacing, okay, the highway Federal Highway Administration has given the spacing rule for spacing for boreholes. Here is another table proposed by this reference for spacing. Okay, if you have a multi-story building between 10 and 30 for the spacing, one story industrial plant between 20 and 60. Highway, if you have highway between 250 and 500. Residential subdivision also between 250 and 500. And dams and dikes 40 to 80. Okay. So spacing can be increased or decreased depending on the condition of the subsoil. So if various soil structure are more or less uniform and predictable, few boreholes are needed than in non-homogeneous soil structure. So if your soil is uniform, you have less work to do. But if the soil is not uniform, you have to do many boreholes. That's the meaning, okay? Because now we are in the boring, soil borings, okay? From here, now we are in soil borings. What are the methods we use for borings? The number of boring depend on the project's size, number of foundation, and the site used. For foundation, this this is the recommendation of the Federal Highway Administration. Okay, for this number, this spacing is recommendation of this reference. It's used also in practice actually, and this now is recommendation of the Federal Highway Administration. So the foundation boring depth is influenced by the foundation geometry and loading. Okay, for roadway, the hand auger investigation, hand auger, we will see this soon enough. For every 30, let's say 30.5 or 30 meters along the central line to the depth of 1.5 meter is typical. Okay, so if you are building a road every 30 meters. For bridge foundation, boring are more frequent and deeper with a minimum one boring at each pier location to the depth of 3 to 5 foundation diameter below the anticipated foundation. Building with large column load often required a boring at each column location unless soil conditions are highly consistent. For critical structure, more detailed subsurface investigation and amplification factor on the load are required to make sure that the probability of failure is low. Okay, this is recommendation from Federal Highway Administration. A critical structure means very important structure, for example, hospitals and this kind of structure. So we also should take into account the ultimate cost of structure when we are making decision. Okay, that's why in general the cost for the site investigation should be between 0.1 to 0.5% of the cost, the total cost of the structure. Okay, so we should consider that the expenses are not going beyond this interval. Okay, so soil boring can be made by several methods. So we are going now to see what are the different methods used for borings, soil borings. Auger borings, wash borings, percussion drilling, and rotary drilling. Okay, so we will see all these now, one by one. So in most cases, the cost of the subsurface investigation is justified by cost effective, as I said, of foundation design. So uncertainty in subsurface condition sometimes lead to over design. So we have to be certain that this subsurface is good so that we can limit the over design. So designer must consider the site variability and appropriate testing to increase design confidence and reduce the probability of failure. The soil sample obtained from this boring are highly disturbed. Please, we have to be careful. In some non-cohesive soil or soil having low cohesion, the wall of the boring will not stand unsupported. In such condition, we need to use to support, to use some casing to prevent the soil from caving in. Okay. So the soil is disturbed and some soil are not stable. If you dig a hole, if the soil is not stable, the soil will cave in, the soil will fall. So in that case, we need sometimes support, okay? The casing to support the soil. You will see what I'm talking about very soon, okay? Let's now talk about the type of uh, material, type of method, different type of boring method. We have hand augers and continuous fly augers. This kind of thing, hand, there are many types. You can use this just by hand doing this or this kind of thing. See this one here and this one here. This guy here is using this type and this one is using this type. Okay. So this can help us to do boring up to sometimes 3 meters in the loose and maybe moderately dense soil. Okay. So no need heavy equipment in that case. If you're going only to like 3 meters in the ground. Sometimes if you need to go deeper, okay, we can use mechanized augers. Okay. But for this flight auger, it is this one. Sometimes we can use this one also. Mechanized, this kind of machine can help us to go deeper than 3 meters for the case of a loose to medium dense sand or soft clay. A qualified person should observe the soil texture, color, and type at different depths and prepare a boring log. This method is called like a sample boring. So as you can see, observation also is necessary in this kind of thing. Okay. If we have hard soil, hard strata, we may use what we are calling here wash boring. Okay. Wash boring, it includes many types. Wash boring, as you may guess, we need water to wash. Okay. This is when the soil is very hard, sometimes rock. Okay. This technique use rotary cutting tip and water circulation system. Okay. Cut and transport material to the surface. Okay. This is example. So you can see the tips here. This rotary cutting. Okay. Maybe here it is rock. So you cut the rock here and you can see this water is coming here, water injection. And then this water is being pumped, it's going up here. And on its way, it will carry the soil that is being cut here. It carry out the soil. You see these arrows are going up, right? Okay, then it will come here. This first tank, if you can say it like that, is used for settling. This is normally for oil, but it's the same concept. So we can see here that the soil will settle here. The settlement of soil will be done here. And then the water will continue here. Because we know that soil cannot float, right? It is not floating. The same system is shown here, you can see. Okay, you do this, and the water is put back inside. By the mean of this pump, we can pump this water back inside. You see this going back inside and pumping the soil out, something like that. Okay, so rotary drilling use rotating bit on drilling road to cut soil and advance boring suitable for sand, clay, and rock. This is same as what I explained. This is one example of what I said right now. Okay, this is uh, same as this one, washboarding. So this is cutting the soil. Okay, and we were talking about support. Maybe this kind of thing is supporting the borehole so that the soil will not collapse inside. So this drain, this equipment will be breaking, cutting the soil. Okay, rotating, it's rotating, and the soil mix with the water, maybe mud, it will be like mud, goes up here, and this tank is settling tank. Soil will settle here because soil cannot maybe float like that. And up here, maybe we have mud that is floating. It carried here, and then from here, the mud or water is being pumped back inside here, and it continues. This is an example again. Okay, because if you have rocks on your side, you cannot do this kind of method. You cannot use this hand auger. Okay, impossible. So if you have hard soil, these are the methods we are using. Okay, so the water or drilling mud bring cuts to the surface like this. The soil you are cutting here is brought to the surface. Okay, with borehole ranging between 50 to 203 millimeter, the larger of the diameter of this borehole. Okay, so drilling mud prevent like caving, and sampler replace the bits for soil sampling. You see this bit here can be replaced by sampler, and it can help to sample, make soil sample. Air is also used sometimes in environmental drilling. We have also this kind of drilling method, percussion method, that is chopping the hard soil, it cutting also the hard soil and rock by maybe you raise a very heavy equipment and drop it, something like that. Okay, this maybe if there is a rock here, you lift it and you drop it, gravity, and this device, percussion device, will hit the rock inside to cut it, to make it, to break it in pieces. This is a photo. So casing may be needed. As I said, this is casing, see, because the soil is disturbed too much and some soil cannot stand it. Okay, I think that all for this first part, this first video on this chapter number 2. And I hope we did something, you did understand something. So we will stop here and come back again for the rest of this chapter. Okay, thank you very much for your time and see you soon.